everyone, this is Maurizio, editor-in-chief of powerelectronicsnews.com, and welcome to PCIM showing in Nuremberg. Today I have the pleasure to be here together with Edoardo Merli, Executive Vice President, Power Transistor Subgroup Automotive and Discrete Group at STMicroelectronics. Ciao Edoardo, how is it going?
Ciao Maurizio, I'm fine. How are you?
Good, fine, very busy. And you?
Yeah, quite busy as well. I mean,
Good.
it has been a very busy day today.
So PCIM is one of the most important power electronics conference. So tell me, what's news from STMicroelectronics? In particular, I have attended a couple of days ago the press conference about your latest announcement, the fully vertically integrated in Catania, the Silicon Carbide Valley.
Yeah, I can say a few words there since we met there for the big ceremony we had with Mrs. Vestager and then Mr. Urso, I mean, the Minister of Italian Enterprises there. So you have seen, let's say, how big is our investment on silicon carbide, I mean, which reflects our total commitment on silicon carbide and on power. So that is, as you said, I mean, the first European vertically integrated silicon carbide fab from substrate to final products, because it does host as well a backend factory there. And then it is a big one, so because I mean we are talking about $5.6 billion investment with a big grant coming from the European community, and then from Italian government there. So
talking about a big topic that I would like to share with you is charging infrastructure, powertrain. Maybe we need more charging infrastructure, at least in Italy. So charging infrastructure expansion versus powertrain technology advancement. So which should we prioritize for electric vehicle adoption, or in other ways, how advancement in powertrain, in infrastructure should complement each other, and what about wide band gap semiconductors in this case to accelerate? So they old promise to revolutionize power electronics in electric vehicles.
yeah, actually the two aspects are completely tied and connected. I mean, because yeah, you said that in Italy we definitely lack. I mean, Italy is one of the worst countries, unfortunately, for let's say as far as the penetration of electric vehicles is concerned. And then one of the biggest issue we have is let's say the lack of infrastructure. So the infrastructure building up in terms of charging stations, and then the technology that I mean is used and has to be used in order to sustain, I mean, range for, and then also fast charging time in vehicles are completely connected. So the technology that we are developing, the product that we are developing with different forms, different packages, different solutions, are definitely meant in order to sustain both. And then, okay, silicon carbide and GaN are bringing huge advantages of that. I mean, because silicon carbide and GaN for let's say they're superior compared to silicon performances, electric, let's say thermal behaviors there are bringing big advantages. I mean, in the cars they can make the cars, or they can allow, let's say, the car makers to have, I mean, bigger power density, higher efficiency, and then this leads to, let's say, lower weight, I mean, lower volumes. And then for the charging stations, the modules, the discrete solutions, again, using different technologies, I mean, silicon carbide and GaN as well, they can lead to much, I mean, powerful charging station, much more efficient. And then, I mean, towards, for instance, a DC charging station that can shorten very much the charging time. And this is one, of course, together with the range, key parameters for the adoption of the electric vehicles.
Great. So, despite ongoing climate change, the use of fossil fuels, in this case, remains one of the major source of global energy, of power generation, if you are considering the sector globally. So we have to reduce CO2 emissions. We need to increase efficiency. Talking about power electronics, each of us should take the first step to reduce our emissions, if we can say. So talking about industry and talking about your company, what about path in terms of decarbonization and sustainability from STMicroelectronics point of view?
Yeah, we have, a quite aggressive plan on that. And then the plan is a global plan. So we have a plan, of course, to reduce, the direct emissions, the direct greenhouse emissions on all, our industries and factories there. We have a plan to save energy there and to have, our factories and fabs, supplied by green energy.
Yep.
We are also asking our suppliers to, let's say, to declare their own, energy chain, if we can say that, in order to guarantee, as far as possible, an end-to-end, green energy there. And then, coming back to your points before, what we are developing in terms of power solutions, going towards, higher efficiency. So definitely for the new material, silicon carbide and GaN, but also for the more efficient silicon technologies, this goes into an energy saving, and then, of course, at the end, in, a reduction of the emissions themselves.
Yeah, thanks. So, last question. Looking forward, let's have a look at the future. So, what do you see the next trends, the next innovation in power electronics? Maybe something about game changers like technology, but also in particular, which the companies. The goal is to stay competitive, to capitalize on these trends. Which considerations should keep in mind the companies?
So then maybe I can start from automotive. So one trend that we are seeing is definitely higher voltage coming from from the batteries, and then a higher voltage battery bus. This, of course, has a lot of advantages because it allows to have a reduction of harnessing. It allows to have better efficiency, and then, of course, it reduces the charging time. So again, this translates into a better perception for the users. And then this is definitely a trend that we are seeing. And then this, also responding to the second part of your question, for us means that we have to develop solution at a higher voltage that, can cope with that, and then can, allow us or our customers to address these questions as well. So moving to the industrial, so what we are seeing is a lot of applications on the energy storage. We are seeing more and more as well, so some high voltage DC link type of applications. And then this definitely with, namely with the silicon carbide, that high voltage can be addressed, quite efficiently there. And then there is another big trend, which is definitely a larger trend than power, which is the data servers, the artificial intelligence servers. But those servers, they require, a huge amount of energy. They require to be cooled down. And then once again, the energy efficiency and then the power supply using silicon carbide and GaN in the future are really a key enabler of this massive development of servers. So we are developing solutions for all these trends, and then we are keeping innovating on the technology themselves, even on the material. So we mentioned the substrate before, but then material for the backend modules and then processes are definitely another key area where we are working on.
Okay, thank you so much, Edoardo. Grazie mille.
Thank you very much. Grazie.
See you next in Milan for Power Up, where you will talk in the second day about wideband gap.
Yeah, see you in Milan in September for the Power Up event that you are organizing. And then definitely I will be more than happy about sharing and then presenting, the silicon carbide and GaN, direction trends there. And then, we will be waiting for everyone coming over. Good. And then
looking forward.
Listen to us. Thank you very much. Then.
Thank you. And thanks for watching, and stay tuned on powerelectronicsnews.com. Thanks.
Thank you very much.